Hello everybody, thank you for joining in today. My name is David Eagle from OneSpatial, and this session is going to look at tips for performance tweaking your FME processes. So we're going to look at some tips and tricks and some ways in which you can set up your system, your resources, your FME processes to try to get the most out of your hardware, but also to get the most out of your data. So thank you for joining us. We've got a good few people signed in today, and we have got a chat window for you to enter questions into throughout the session. You're welcome to do that. My colleague Hayley is going to make a note of those questions so that I can respond to them at the end of the session. At the end of the session, we'll also open up the audio line, so if anyone actually wants to talk to us in person, you're more than welcome. As I say, we'll have the chat window open. If you put a question in at any point, I may try to answer it at that point, but if I don't get to it immediately, it'll be towards the end of the session. This is the agenda for today. Two main topics, really. Initially, we're going to look at system resources around your machine. Looking at the best way in which to set up your hardware for FME to get the most benefit from your processing speed. So we're going to look at the location and the use of temporary files and how FME handles them. Look at reading and writing data, where it's best to put your data for FME to be the most performant with it. How your processor and memory impacts the process that you might put together, whatever you're choosing to translate or transform or restructure with FME. We'll also be looking at the physical flow of data through an FME workspace. So we make no bones in the fact that this is a technical presentation looking at the capabilities around FME. Some of what I'm going to be discussing today is actually relevant for general IT usage. Some of it is specific to FME. Hopefully you'll find it interesting. We'll try to give you as much information as possible around the tool and the two topics that we're going to be covering. I'd like to give us a brief overview, though, to begin with, of who we are. I will keep it brief. This is a demonstration around the technology after all. OneSpatial have been in the market, in the GI market now for a good number of years, and we work with a significant number of industry sectors. The main technology partner that we'll be talking about today is our relationship with Safe Software. Safe Software are the vendors of the FME product, which we're going to be focusing our attention on. We have a number of certified staff in a number of different technologies. The technology that is important here, though, is FME, and our certified trainer and professional capabilities around that technology are very important to us. So all of our staff that are focusing on the FME capability will all have certified status of one description or the other, and in some cases, like myself and a couple of colleagues, both accreditations, which are renewed every 3 years. So you can be sure that we hopefully have the right skills to work with you on using the FME product. Safe Software themselves have been around for 20 years. Last year was their 20th anniversary year, and they have very much positioned themselves as a tool that sits between a lot of the different environments that you can see logos for down there, and that's really just a handful of logos. FME, as of the latest iteration of the tool, supports 336 different formats, which in FME 2015 is a big jump from the previous build. A lot of the most recent format changes that have been added in are relating to formats and environments that are in the cloud. What I'll also just highlight quickly is that the FME product comes in three different flavors, if you like. So there is an FME desktop tool, there is FME server, and there's also FME cloud. And FME cloud is FME server in the cloud. So it's really two primary products, in this case three platforms, that encompasses the FME tool. We have a lot of focus within OneSpatial on the FME technology stack, and we have dedicated personnel to work around the tool, and we do a number of things. One of the things that we spend a lot of our time doing is helping potential customers understand exactly what FME can do for them. Also, a significant part of our time is around helping existing customers to do more with the FME product. It's a very broad-ranging tool that has a lot of capabilities, and we want to make sure that if you buy it for one particular task, that actually you can deploy it in a number of different places. So we have a number of different services around consultancy and training and technical support offerings to help you do that. Anyway, enough of that. Over to the main focus of the day, really. First section of the session is looking at managing system resources, and what we want to try and do is take a little bit of the well, I guess highlighted by the image there, take a little bit of the praying out of your processing, where you're not entirely sure what's going to happen next. I want to give you a little bit of an understanding of what's going on under the bonnet of FME, to hopefully allow you to be a little bit more informed about how FME is working. So we'll try and dispel that problem, and starting off on the topic of temporary files. So straight into a reasonably technical topic around temporary files. So some of you may be aware that when you hit the green Run button on FME Desktop, what that does is it reads your data from wherever, whatever format or structure you're holding it in. So it might be in an Oracle database, it might be a MapInfo tab file, or an Esri shapefile or geodatabase, or you might just be reading an Excel spreadsheet. But as soon as you consume that data into your FME process, there are a number of potential points through different transformers where some temporary data will get cached to disk. So the default installation of FME when you install it on your C drive means that by default the temporary information will end up on your C drive. Through our support desk, we've seen that there are occasionally support cases from customers where we've found that FME has failed to complete a process, and it's often in an environment where an organization has a default approach of installing software where they have partition drives. So let's say you have a machine that has a C drive and a D drive in it. The C drive can often be reasonably small. That's often the default location to install your data, your application, I beg your pardon, and the temporary data will get written to that location. The FME log will report that you've run out of space, and sometimes customers think that the space that has been run out of is actually where the data is being written to. Well, actually, quite often that will be the fact that the temporary space has run out of size. So a partition drive, when you have a small C drive, can sometimes cause this problem. The way of getting around it is to make sure that you define your own temporary location. Now, what FME does behind the scenes is it looks for a number of different things to indicate as pointers to where you'd like your data, your temporary data, to go to. First of all, it'll have a look to see if you've got an environment variable called FME temp or temp. It'll also look to see if the folders temp or TMP exist. If none of those exist, which is pretty unlikely to be honest, then FME won't actually run. So what I would recommend is that you probably try and take things into your own hands and actually initially set your temporary space yourself. So if you take control, FME temp is the environment variable you want to define. So what does that mean? How do you actually do that? Well, you go to the start button on your computer and find the computer option and right click and go to properties, and you'll get a window up that looks a little bit like this. Go to advanced system settings and the following window will appear, and you can see that you have the option for environment variables. Some of you in more corporate environments may need to talk to IT to help you to do this, but you can see that here's a few of those environment variables that I was referring to. By default, what I've done is set a system variable called FME temp. And FME temp is the primary environment variable that helps you to direct your temporary files to a specific location. So what I've done on my machine, if I just go and locate my temporary path, and you can see that I have a folder on my C drive called here C FME and FME temp, and here is some of my temporary files from a previous process. So all you would do is create a new temporary file. If I edit the existing one, you need to put in here FME_temp and then path up to the directory that you've created, and that's where all your temporary files will go from that point. If you want to go and read up a little bit more about that, then the place to go is off to FMEpedia, and if we go and have a look on FMEpedia, you can see here that there is a document, an article around the FME temp environment variable. So go to fmepedia.safe.com, type in FME_temp, and you'll find the detail around that environment variable. So the other thing, and the reason why the image of the SSD, the solid state disk, is over on the right hand side there, is that if you happen to have a solid state drive in your machine or on your server, and you can point your FME temp space to that location, then you may make quite a difference to the performance of your FME processes, because FME can get data information back from that disk and its temporary files much quicker. So that can be a real bonus if you have that kind of technology available to you. Moving on then, and taking a look at the disk read and write speed. As I mentioned at the start, some of this is not specific actually to just processing with FME, so it's worth being aware of. The point here though is that where you read your data from and write it to can have a great deal of performance impact. The trick really is in that statement there. If possible, what you should try to do is get your data as close to FME as you possibly can. So if we go through this scenario, and hopefully you'll really enjoy my animated GIF there. Hopefully that's coming through to you at the other end. What we've got there is a spinning disk and FME, and the box around that little animation there is actually highlighting that what we've got is a single machine. So FME is installed on a single machine. It's reading and writing from a disk. The scenario here is that what you'll find is if you read data from the same disk and try and write it back to the same disk, then actually you can have some performance degradation, because the disk is spinning to supply data to FME, and it's also spinning to write data back down to that disk. So it's not always the best solution if you're trying to do that. You can find that there are more performant ways of reading and writing data, and one of those is a scenario where you have two separate environments where you may be reading data, in this case reading data from one disk in a machine that FME is installed on, and writing your data across to another disk on another machine. The weak link at this point though is often the transfer mechanism from your machine to that other machine. If it's a USB, then obviously if you can get a USB connection that is as fast as possible, that's useful. You go for USB 3 connection technology. That will speed up the transfer of data. What you also need to be aware of is often if it's a USB connection, it's probably an external hard drive, and those external drives often have a slower spindle spin speed than some more common installed hard disks in a machine. So a typical external disk has a spin speed of about 54,000 RPM, and standard hard disks in machines often have 7,200 RPM or much greater in servers, 10 or 15,000 RPM in some more premium servers. So that's going to make a difference for the speed at which data can be transferred to FME. The other challenge can be sometimes if you're getting data or writing data across a network, if you're trying to do it at a busy time, or your automated process happens to coincide with when your environment's backup is run and data is being pushed across your network, then that can slow a process down. So whilst we recognize that this isn't always possible, probably the most optimum solution is to have the ability to read data from a disk on a machine and write it back to a different disk inside the same machine. As I say, that scenario isn't always possible, it's not always practical, and especially if you've got to download a whole load of data from a server to a local machine, that takes time in itself. But just to be aware that those are some of the issues that you need to try and optimize where possible. And you'll find that actually the performance difference you can get out of a process by putting your data in a more optimal location can be quite significant. We had an anecdote from a customer a little while ago who went through a number of optimization steps, including making sure their data was in a better position, and not just including this one bit of capability, moving their data, but with a number of processes. They went from having a 19-hour process to a 3-minute process. Made as you can see, a fairly significant difference. But there were a number of factors at play, and the location of the data was one of those. Processor utilization is another topic to be aware of. FME is not a multi-threaded application, which basically means that when you fire up FME Workbench and press run, it will use one of your cores on your machine. The laptop that I'm using today, I believe, has got 4 cores, so FME gets to use one of those when it's running a job. That said, a number of transformers in FME, and it's an increasing list these days, have the ability to effectively use their own core. And that capability is highlighted here in the dissolver transformer as a parallel processing level. The parallel processing level by default is set to no parallelism. However, there are 4 other options, which are minimal, moderate, aggressive, and extreme. Those 4 levels translate into this information, and this can be found in the FME help guide. And what you can see here is that no parallelism effectively means that only one core will be used, so you're not making any changes there. If you go to minimal, as I said, my machine has 4 cores, which is minimal equals cores divided by 2, so I would be able to run an extra 2 processes on my machine at the same time. Moderate is 4 cores for myself, and aggressive would be 6, and extreme would be 8. So you can start to see that those latter capabilities, you need to be a bit careful with them. Obviously, if you're trying to run more cores than you've actually got, then you can end up slowing your process down, not making it faster. So it very much depends what you want to do. If you're making, for example, HTTP requests or requests across the web, then aggressive and extreme will be fine to use. But if you're actually doing some heavy geometric processing, then probably you want to stop at around the moderate point. It is necessary to have the ability to group your data in order to use this technology. So you can see just above the parallel processing level there is a parameter that says group by. You have to be able to group by. So for example, if you wanted to take postal or zip code data that had very detailed unit-based polygons for a country, and there was a hierarchy in that zip code set up so that a number of postcodes fall within a larger region that is perhaps a postcode district or a zip code district. If you have many districts, then what you could do is group by district name, and then let's say you went to the moderate level. What that would do would spin up a number of additional FME worker.exes in addition to the existing FME.exe. So effectively you could dissolve, in this case, the boundaries for four districts, postcode districts at the same time. So in theory you could perhaps improve your performance by 4 times in that scenario for that portion of the process. This is very much a capability that you should deploy with some fairly serious testing to see what benefit it gives you. If you don't have the ability to group by, if you don't have an appropriate attribute, you could put a dummy group into your data by using a transformer like the modulo counter. It's a very handy transformer that allows you to add an ID that stops at a certain point in your to your data. So you could say, go and give me my data. Every feature gets an ID, but only up to a count maximum of 3. In that case, you would allocate your data to different groups, which you could then group on and do some parallel processing. The other thing to be aware of is that if you wanted to add the parallel processing capability to any transformer, you can just turn it into a custom transformer, and you have the ability to add a parallel processing level in at that point. Again, FMEpedia is a good location to go to for this technology and this discussion. Go and have a look for parallel processing on FMEpedia. There is a very good article there with some examples to download, and it also includes a little bit more detail about some of the performance differences that could be seen with some certain processes in here. So you can see that, for example, this process here took 1 minute and 10 seconds without parallel processing, but as soon as you used moderate capability, that dropped it by over half in terms of performance capabilities. So do go and have a look at that article. Very handy little document to take you through that capability around processor utilization. Just finishing up on the processor topic, though, there's also a little bit of capability around the run itself in FME. Certainly having, if you don't have an enormously capable machine, certainly having more than one core still means that FME does at least get a core to itself. But since FME 2011, a few years ago now, there was a pause translation button added into the FME Workbench application. So if I just go and get FME and drag it onto the canvas here, and just show you what I mean by this, and actually I'm going to have to break the slideshow just for a moment. You can see that what I've got here is quite a bit going on my machine. So you can see in the top here, this is the processor utilization, this is a memory utilization going on. I've got a few applications running on my machine right now. So whether we're going to see this in too much detail, we'll have to find out. But what I'm going to do is put a creator transformer on screen and a logger, and I'm going to set my creator to go and make me 1,000,000 dummy features, and like so. Probably not quite, doesn't really matter for the sake of the exercise. And if I run this as is, what I'm expecting you to see is that the processor arm of this little diagram here, this little application will get a little bit further round into the yellow there. So let's see if that kicks up a little bit. There we go. It's gone into the red. So what you can see here is FME is firing through all of those features into the logger, and I can actually pause that at that point. As soon as I pause it, hopefully what you'll see is that the processor drops back down again. So by pausing, I get my processor back. I get a little bit of slack on my machine. And the scenario there is, let's say that a colleague, after you've kicked off a process that's going to run for a few hours, a colleague comes over and says, can you go and fire up another application for me? Launch MapInfo, or launch Esri, or launch Intergraph, or launch a particular application, AutoCAD, MicroStation, and go and make me a map. And you might not have enough system resources to be able to fire up that application and work on a process in as easy a way as possible. So instead of having to stop your process, you can just pause it. You will not get your RAM back, but you will get some processor capability back. Once you've finished working on that other application on your machine, you can then push the run or resume button and your workspace will pick up where it left off, and you can see that my processor now spins back up again. So that's just a little tip on that front. It can be pretty handy to be aware of. If we go back to the slideshow, what I can show you here is that also the other concept to be aware of is that the other product, FME Server, when you buy FME Server, you buy engines. So you buy the ability to have multiple concurrent processes. When you work with FME Server, you need to be looking at having one processor per FME engine. That's a bit of a topic for another webinar, but I just wanted to drop that in for any of you that have signed in that have already got FME Server. Hopefully that'll be handy to be aware of. On the memory management front, just having a look at some of the other points here. It's worth being aware that there is a concept of something called virtual memory. Some of you may be familiar with that already, so it's something that you can go and have a look at on your machine. Again, you go to My Computer, you go to Properties, go to Advanced System Settings, and you get the same dialog up that we saw earlier on when we had a look at environment variables, but here you want to go and have a look at performance. Again, in some corporate IT environments this might be locked down. You may need to talk to your IT guys to help you out here, but what you need to do is have a look at Advanced, and you want to look at your virtual memory. Virtual memory, for those who aren't familiar with this term, is effectively a hard disk on your machine that you allocate to be, if you like, pretend memory. What that means is that you will allocate, if you allocate some hard disk space, it is then not available for you to write to in terms of standard data. So you have to be aware that you will reduce your hard disk size on your local machine by setting this up. Quite often this is a system managed size by default. What you can see is I've set this to a custom size so that I've allocated a portion of my physical hard disk to become temporary space. Now what this means is that if your process is particularly memory hungry, if you're throwing at FME a significant volume of data, millions of features that are very complex with a lot of different attributes stored on them, then what you're doing is increasing your chances of everything being good at the end of that process by effectively allocating some hard disk space so that should your process run out of memory on your machine, it will start caching extra temporary files to disk, and it will pass that information back to FME as if it were standard memory. So in the case of the discussion we had before, the faster the disk the better, but what you'll find is your process may slow down if you're using if it ends up using virtual memory, but at least it won't stop. So do go and check what your virtual memory status is on your machine. When it comes to operating system as well, 32-bit operating system, if you happen to have one of those still, then in the case of applications like FME, they can only address 2 gigabytes of RAM, so that's all they get allocated on a 32-bit operating system. So you'd have to install FME 32-bit on the 32-bit operating system. FME by default would only be able to get access to 2 gig of RAM. There is a capability called the 3 gig switch, which is a boot.ini hack. I sort of highlighted at the start of this session this might get a little bit technical. I'm really just going to point you at this article to go and have a look at it. If you do still have a 32-bit operating system, then go and have a look at the help file in FME, and if you just go and search in the help file for /3GB switch, you will find the details around that capability. And what that means is that from FME 26 version GB, so there was a release of FME called FME 2006 GB, that build of FME supported this 3 gig switch, which effectively means that if you have a 32-bit operating system, you could add an extra gig of RAM to applications so that FME had a little bit more capability. That's certainly a less used requirement these days with more capable machines on the market and the move to 64-bit operating systems. Certainly at this stage, 32-bit Windows FME on a 64-bit operating system is pretty darn good from our estimation. It means that your FME can get access to 4 gigabytes of RAM from your machine when it's on a 64-bit operating system. So that's a pretty handy capability. 64-bit FME has been around in a number of different operating systems for a little while. Certainly on the Windows platform, 64-bit FME has been around since FME 2011. If you go and have a look at the safe.com/downloads site, you can see that what you've got there is a number of different installers. 32-bit FME for Windows, 64-bit FME for Windows. There is a 64-bit Mac OS X, which is a technical preview, and likewise 64-bit for Linux available to download on that site. If you're looking at the Windows side of things, then do go and read that article. There are a couple of things to be aware of. The one thing at this stage is that 64-bit Windows FME does have a number of formats that are not yet available on that platform. Our advice at this stage is that you should stick with 32-bit FME on a 64-bit platform for the time being, unless you have a very specific reason for using 64-bit FME on Windows. The main things to be aware of there is that obviously if you put 64-bit FME on a 64-bit OS, you do have the ability to address the majority of the RAM available. However, if we go and have a look at the formats page on safe.com, you can see that if you sort by platform, then there is a little option down here to sort by platform. You can see that, for example, if we go and have a look at PDF as a particular format, it is not possible to write 3D PDFs using 64-bit FME. So that is due to change, and some of the other formats are being added in as well, but right now, as of today, there are a number of formats. So for example, if we have a look at Esri, I believe the personal geodatabase is not supported on 64-bit Windows, and in some cases this is not Safe's the problem that Safe have got there. They're restricted by the vendor who doesn't have yet 64-bit support for their own format. So just a few things to be aware of on that front. Okay, changing tack then from the general resource side of things, let's have a look a little bit more at how data actually moves through the FME product in its own right. In this case, we're looking at the flow of individual features through an FME workspace. So, The first thing to be aware of is that there are a number of rules that are handy to know about. Features in an FME process are processed through that workspace in the order that they are read. The photograph there of people queuing up outside the post office and slowly feeding into the post office is the way in which data passes through the workspace in order. Very, very British perhaps example there, but not to worry. The data is read in the order that the data is in the source data set. So if you have, for example, an Excel spreadsheet that you're reading into FME, the first row of data in that spreadsheet on the particular sheet that you're reading is the first feature that enters the workspace and moves through the transformers. The second feature will be the second row, etc., etc. And the data is read in the order that the format, the reader appears in the navigator. Don't worry, I'm going to show you examples of this very shortly. Effectively, if you have more than one reader in your workspace, reading in data perhaps from Excel or perhaps from MapInfo and from Oracle, then the reader that's listed first is the one that will send its data into the workspace first. The order of the data in the workspace only changes due to a particular transformer. So if you have a transformer like the sorter, the data will exit that transformer in a different order to the order in which it went into that transformer. Understanding the order in which data moves through a workspace is very important for a number of different tools and capabilities in FME. For example, if you're working with variable setting and retrieving, knowing how features are moving through a process is vital. Looking at Rule 1, some transformers can really take advantage of this rule. I've just included a small screen grab from 3 different transformers here, the clipper transformer, the aggregator and the feature merger. And these are just 3 transformers that have the ability to manage or for you to manage how the data is treated as it enters the process. For example, with the clipper, this has a clipper type which allows you to set it to clippers first. Now what that means is that the polygons perhaps that you're using to do the clipping, the clippers, are going to arrive inside that transformer before the clippies do, the things that are going to get clipped. And that means that the clippies can immediately start to be clipped and released from memory. The aggregator in this case means that if you have a group that you have got set up in your data, let's say that the data has an arbitrary number and you pass it into the aggregator transformer to group the features together. The first feature is a number 1, the second feature is a number 1, the third feature is a number 1, the fourth feature is a number 2. The aggregator, when it receives the number 2, knows that it's had all of the number 1s and can therefore group together and aggregate the features that are in the number 1 group and then release those from memory, safe in the knowledge that there will not be another number 1 at some point in the future of reading that data. That can have a big impact on your memory usage. The feature merger is very similar, and you have the ability to pass in suppliers and requesters. Again, passing in or being able to determine whether suppliers are passed in first or not can improve the performance of the feature merger transformer. Just to show that with a bit of a diagram, we'll walk through this example here. This here shows a reader and 2 readers, one listed first in the navigator, then the second reader, which is the polygon that's going to do the clipping. The clipper transformer set into single clipper mode, and we have a writer on the other end here. So what we're doing here is going to pass in a feature followed by another feature and another feature. So we've run the process, and the first reader listed sends its features that are then held in memory in the clipper. The second reader then sends its feature that's going to do the clipping into the clipper transformer, and now what happens is that out pop all our data, all our features into the target writer. If we use exactly the same workspace but do a slight adjustment on the way that the readers are set up and the parameter that's used in the clipper, what we can do is swap that so that the first reader that's ordered in the navigator is actually the one that contains the polygon, and we can set the clipper to use clipper's first mode, which means that we can then send in the clipping boundary, which is then ready and waiting for the clippies, the things that are going to get cut, and we can send those in and they can immediately be clipped, and the part of them that hasn't been clipped can be released into the writer, which is a much less memory hungry process. Now obviously in this example you probably wouldn't make a lot of difference to the speed of the process because of the volume of features that you're using, but the key thing to be aware of is the peak process memory usage. You can find that even if you don't improve the performance significantly, you will likely decrease your usage of memory, which will mean that as you scale your process to a lot greater number of features, then perhaps what that will mean is that you'll have a more likely, more robust process into the future as your needs change and your volume of your data increases. Moving over and looking at features, rules 2 and 3. Rule 2 is the fact that features are individually processed as far as possible in your workflow, in your workspace. And rule 3 highlights that a group-based transformer holds all features until they're available for processing. So what that does is it introduces a little bit of extra detail into this topic. Rule 2 there means that any data set that's listed in the navigator sends its data into the workspace, and it will pass through the workspace as far as possible. And Rule 3 is referencing the fact that there are different types of transformer. Classically, there are two types: feature-based transformers that will operate on one feature at a time, and then operate on the next feature and the next feature and the next feature, but all the time being able to release the feature after it's had whatever needed to be done to it applied. Group-based transformers, by their nature, have to operate on a group. So what that means is that in the case of the statistics calculator, if you're calculating the average area of a particular asset, then obviously you need to know and have received all of the assets that you want to calculate the average for prior to being able to calculate it. So in this case, if we run our process and send our first feature through the workspace, the area gets calculated, the attributes get copied, and then it can't go any further than the statistics calculator. It stops at that point. Those features all make their way to the statistics calculator, at which point the average can be calculated for the group, and then those features can be released from that transformer in the order in which they arrived. And there we go. So key set of rules highlighting how features process through a workflow. And really, just to conclude this this webinar, there's a couple of technologies that you can use to help you out and to understand how features are moving through your workspace. One of those technologies is called breakpoints. FME 2015 has revised the name of this technology and refers to it now as breakpoints, but previously, if you knew this as inspection points, it's the same capability. There is a button on your toolbar which has a magnifying glass against the play button. Once you've added breakpoints to your process, then that's how you have to run the process in order to see the results. So this has been around, the inspection point capability is around since FME 2011. What we'll do is I will just open up a little workspace to show you what I mean by this. So if I just put this workspace onto screen, what you can see here is that I've previously added a breakpoint or two to this workspace. If you want to add a breakpoint, you can choose Add Breakpoint. If you want to remove one, you can disable or remove it. If I run this process as is, what we'll do, just hit the normal run button. Those breakpoints are ignored. You're not doing anything in that process. You are literally just processing the data. So you can see the features move their way through the process. What you can also see in the navigator window, based on the topic I've outlined, is that this reader is second. I can move the order of the readers in this process, or you can right click and you can move up or down. If we leave the data set here that is the clipping polygon to be read second, and if we run this process using the run workspace with breakpoints option, what you can see is that the first feature that actually is read and shown at this point appears in this feature inspection window, and I get to see the first feature at that stage. If I then step to next connection, the second raster passes its way to the clipper transformer and then waits in memory, and then what we get is the polygon that's going to do the clipping making its way through each transformer, and you can see that highlighted in orange as it steps its way through, and now it's arrived, and now the raster data can get clipped, and out it pops and the workspace completes. Whereas if we restructure this a little bit and put our industrial area up above and now run this with our breakpoints, what we can see here is that the first feature that enters the workspace is actually the polygon that's going to do the clipping. It makes its way all the way to the clipper transformer, and now the raster data makes its way and immediately can start to get released and written. And then what you're looking for is hopefully an improvement on your peak memory usage. Now actually, with this particular workspace, because it's such a small volume of data, I don't see a massive difference. I do actually see a little bit of a difference, but you can imagine that you can start to see some fair differences with a greater volume of data. Breakpoints are really interesting technology. There's a lot more capability to breakpoints than just what I've shown you, but it's also a very useful capability to help you debug a process and understand exactly which data is going through which part of the workspace at what point in time. Taking that to its natural conclusion, SAFE in FME 2015 have introduced a capability called full inspection. And I have to say that of all the new features of the 2015 release, this is a true debug mode, and it's probably going to be extremely popular with general FME users. I know I've used it to a great extent already, and I've been really pleased with how it's working out. What it means is that you run the workspace, and at every stage of the way you will see some little numbers that appear, and that is a cache of the data at that point in time, and you can go and inspect it straight away. You will also see that any port that you haven't connected to something, if any data comes out, is effectively likely to come out of there, you'll get to see that too. So if I just take us back to that exactly the same workspace, close down that breakpoints window, you'll need to add this extra button onto your canvas. So run workspace with full inspection. If you want to go and find it, you need to go and click into customize the toolbar, and it'll be in this box. Drag and drop it up to the top here, if I run with full inspection, you'll see that hopefully I get lots of numbers all over the process. Now you wouldn't want to be running your workspace in full inspection in production, because it will be obviously a lot slower and it's going to be storing a lot of temporary files. But when you're debugging and working out what's actually happening, at any point after any transformer, you can double click on that number and the FME data inspector will fire open and it will show you the data at that stage. So in this case, I can go and have a look at that location just there and see what is in the outside, and actually that now is the data with a polygon clipped out of it. So the two raster tiles with the data clipped from outside. So you get to see every step of the way. So that's really where I wanted to conclude that process. That's a very, very handy extra capability, and really helps you to understand what's going on. As I say, today's session was a little bit technical. It went into some of the nuts and bolts of how features are moving through an FME workspace, but also how you can look at optimizing the setup of your machine or your environment to best be able to cope with a large volume of data. So I hope you found that handy in today's session. If you want to go and find out any more about the FME product or anything that we've talked about today, safe.com is a good place to start. And of course, onespatial.com/FME has plenty of details about the training courses and the services that we offer. YouTube.com/onespatialgroup is the place to go and have a look at some of the historic webinars that we've done, and this one will be recorded and put up there at some point very soon. FMEpedia.safe.com is the website that I've been referring to throughout this session. A number of articles that you can go and have a look at, and definitely get involved in the community answers site. The ability to ask questions of what effectively is several thousand global users of FME is a very handy one for you to engage in. So I'd definitely encourage you to do that. For now though, I'd like to thank you all very much for attending this session, and I'd also like to extend an invite to all of you who've attended to come along to the FME World Tour events that we're running later in the year. We have a number of sessions. If you go to our website, to onespatial.com, and have a look at our events page, you'll see that in May we have a number of sessions that are going on around the country. We have a session in London, one in Cardiff, we have one that is up in Leeds, and we're also doing one in Edinburgh. So 4 World Tour sessions. Those day-long events are free to attend. They're usually great fun. We try and make them as interactive as possible, and we'd love to have you come along and join us there. For now, I'll say thank you very much. If you have any questions you'd like to post, we'll hang online for a little while, and I'll see if I can handle those. So I'm going to go and refer over to the chat window and see what's come in. But thank you very much, and we'd be happy to hear from you at any point in the future. Thanks a lot.